5, part 2, day 3, organic chemistry. Let's see what we can do. All right, using this Hemingway method, meaning I end with something that makes it easy to jump right back into it, immediately gain momentum. I put in the same prompt that I tried for Super Grok/Grok, and it totally just didn't read my image correctly. It did this Lewis structure for a different substance. Oh, excuse me. It was much simpler than the MIT one. I was looking at the MIT problem set and trying to figure all this out. Yeah, it's way better in GPT-4o. So I'm going to stick with GPT-4o for this. For whenever I have an image that I need to look through, GPT-4o image recognition seems to be by far the best. So Grok is awesome for explaining things. It's a little lengthy and wordy, but it did a really good job with the curriculum at least. I'm going to stick with that mostly, but right now I want to look at this. So I look at the molecule's identity. Sodium acetate, the sodium salt of acetic acid, is what CH3CO2. Okay. Na is. In salt form, it loses one acidic proton. That's an H+. So I have a negatively charged carboxylate. That's carboxylate, I guess. CH3COO- with Na. So to identify the atoms involved in the resonance, I'm looking at the carboxylate group. And it has one CO double bond and one CO- single bond. It's negative charge in one oxygen, but it's delocalized via resonance to both. So I need to understand what that means. There are two equivalent resonance contributors. Let me look again at the image quickly. Oh yeah, I didn't get to this conjugate base stuff yet. Let's see here. So looking here, I could see there's the O with the minus. Oh. And there's the regular O with the double bond. The question is why that is a resonance. The negative charge is on one oxygen, but it's delocalized via resonance to both. How do I want to just use this. How do I know that this is where the resonance is? And how do I identify that it's involved in resonance? Use curved arrows to show the electron flow. I don't see the curved arrows. I need to deprotonate the acid. Yeah, stop glazing me. GPT-4o glazes you so much in this fantastic question. This is exactly the kind of insight that sets apart a student who memorizes structures from one who understands chemistry. All right. Resonance happens when you have a pi system or a lone pair next to a pi bond or an empty p orbital. That's because there's an empty p orbital, basically. So there's one unhybridized p orbital available for pi interactions. And look back at this. Where's that unhybridized p orbital? It's that C has this blank p right here. Yeah. Okay, I think this makes sense. I need to see more examples. Rule of thumb, if you ever see a negatively charged O, N, or a lone pair next to a C-double-O carbonyl or a C-double-C carbocation, you almost always have resonance. All right, let's have it test me. And I'll go back to Grok right here. So Lewis structure for formaldehyde, It's going to be CO, HCO. Least electronegative in the center. I need to remember that. What was the prompt that led to this whole thing? This was just asking about that one. Yeah. Pi bonds, sigma bonds. All right. Let me go. What was this? Scrolling on up. Look at this chat. Man, Grok is even wordier than the other one. There we go. Oh, God. What have I done? I lost it. What was your experience with chemistry going into this? Good question, Kevin. Kevin Beavers in the chat. I've tutored chemistry for a few years. 10 years? Maybe 10 years. High school chemistry, never even AP chemistry, just regular high school chemistry. I'm quite good at that. So I have a good understanding of, surface level orbitals and electron dot diagrams, Lewis dot structures, orbital diagrams, acid base stuff. Basically any basic problem solving. So I'm like a high school chemistry student who got an A plus in regular chemistry. No organic chemistry. I only took one chemistry class in 10th grade as a student, and I've tutored that class with dozens of students over the years. So let's look at this. Resonance or not? So phenol, which is C6H5OH. Walk through each answer. Yeah, let's see what they say. So I think that this is going to be, let's double check this rule. I'm going to screenshot this too. Give it like a 3. Negatively charged ON or lone pair next to a carbonyl or carbocation. You almost always have resonance. Okay. Yeah, so let's see. Negatively charged ON or lone pair next to a CO. Okay. Do I have carbonyl or one of those things? Basically, I don't think there's resonance in this one. I think this one, the carbonyl adjacent to NH2, that seems like, yes, there is resonance. Let's just see. Oh, yes, lone pair on the OH oxygen can delocalize. Oh, the OH oxygen delocalize into the aromatic ring. I know what that is. Aromatic ring. It's all those double bonds. Oxygen donates electron density into the pi system. Resonance contributors involve a negative charge spring. Okay. Amide. The lone pair on nitrogen can delocalize. By the way, Kevin, what's your experience in chemistry? I'm curious if anyone watching this has learned OChem before, or what your level of chemistry is. If you have learned OChem, I've gotten a lot of valuable insights from people who actually know organic chemistry in the chat and comments, etc. And part of this experiment is I do want you guys to tell me advice you have, because yes, the AI gives great general platitudes and insights, but individual advice, also individual expertise, always reigns supreme, or at least is a very, very helpful addendum to this just AI professor curriculum. So lone pair can delocalize into carbonyl. This is when they couldn't. No pi bonds or empty orbitals. So pi bonds and empty orbitals. Fully saturated carbon. Okay. Explain what fully saturated carbon with carbon and in general for atoms. And what are the candidates for things that can be delocalized into? GPT-4o is still kind of the goat for this. I mean, I like Grok, but let's see. It's still loading. Super Grok. Mega Grok. Okay. Give me lesson 2 for this curriculum. Boom. I need lesson 3 too, but I think that lesson 2 will cover some stuff. This had an empty p orbital in this lone pair. That's why it had resonance. Not fully clear on resonance still, to be honest, but I'm getting closer. Acetone, enolate. Lone pair on the alpha carbon can delocalize into the carbonyl, forming a CC bond and moving pi electrons up to the oxygen. So it's all about the lone pair. Has a lone pair, but it's not adjacent to a pi system or carbonyl. No p orbital overlap available. The OH group is on an sp3 hybridized carbon. So there's no pi system or p orbitals. Got it. The issue kind of is that I just wouldn't know how to draw these. I asked it another question, didn't I? Yeah. So fully saturated means all single bonds and no available pi systems to participate in resonance. Cool. So sp3 hybridized with 4 sigma bonds. A pi bond, an empty p orbital, an anti-bonding orbital. Lone pair on another atom. I really can't wait to the point where this doesn't just feel like arbitrary random information. What happens if I ask it, why does the universe use chemistry like this, organic chemistry? Explain why this makes sense in terms of just a theoretical physics understanding of the universe and the way to organize particles. Also, are all these organic chemistry particles living technically? Are they able to replicate? Which I think is the definition of living. Correct me if I'm wrong. Let's see how that prompt goes. That's a deep question prompt. This MIT problem set already is getting tedious. I know I'm going to have to just sort of whiz through this. But orbital drawings, empties. So that's why we got the arrows for the sp3. Arrows for the pi bonds because we got empty p orbitals. Curved arrows to show where these can go. Conjugate acid is where I got to, I think. And I'm only halfway through this problem set. Geez. Most acidic, then this, then this. Okay. So the difference between these is the chlorine's location, right here in the middle versus right here. More acidic than non-charged, comparing same atom. Central atom is electron withdrawing. Huh. Okay. Yeah. Kevin, that's cool, man. I appreciate that background. Basically, if you're a lifelong learner, what a time to be alive. The fact that you can plug this all into AI. What I'm most excited about, honestly, with this whole experiment is what I'll do after organic chemistry. I think I will do organic chemistry 1 and 2, but then I sort of want to venture into my own curricula, like just list things that I'm curious about learning that I think would be really useful in my life and empowering to know. Specifically, I want to know just how everyday things work. I think there's a great sort of reclaiming of modernity to be had if you understand on a very deeply scientific level, going from, the atomic to what you actually see, how all the electricity in your house works, how the insulation system in your house works, the things like around your home that you interact with on a daily basis. What's the science between all of these? Material science is going to be important to understand. What makes my bed comfortable? What makes all these things work. Understanding plastics on a deep level, understanding food on a deep level, this is sort of the foundation that I think organic chemistry will be cool to have in the background somewhere, and I'll keep finding ways to apply it and really get that knowledge going on a deeper level. And then I also want to get into some more computer science stuff. I, you know, am a web developer, I'm a software developer. I've made iOS apps, I've made web apps, I've made Chrome extensions. Had some success, not in terms of making money, but in terms of, having good launches on Product Hunt and, you know, having people enjoy the apps. But it's there are gaps in my computer science knowledge that I'd like to have. For one, I'd like to understand large language models and machine learning more and the different paradigms there. So I'll probably do something there, some series with machine learning. I'm giving you guys a whole preview of like the next 6 months of this channel. But and then I also want to do something just on back end setup. It's always the hardest part for me. I'm a pretty good front end web developer, but for some reason I often struggle trying to convert things to the back end. So I just want to get really good at using one system. Like I'll probably pick Supabase. That seems to be a popular one. It's open source. Get really good at setting up authentication, security, and data modeling with Supabase. Probably specifically like SQL database, PostgreSQL, but we'll see. Curious if you're watching this, what are you, a lot of lifelong learners tuning in, which is awesome. What are you learning right now? What are some things that you're interested in studying more? There's no shortage of things I want to learn. So I'm like eager to charge through organic chemistry and move on to things that are more applicable to my daily life directly. Linear algebra was also sort of an abstract one that I thought would just be cool to get back into math. But also important I knew it was involved in machine learning, so AI stuff. Okay, conjugate, woo. I'm just gonna zoom through all these. Rank all the molecules in order of acidity. So I have to understand like what makes all these acidic. Ranking according to acidity. So weird. This is the most acidic H atom. Okay. All right, they're talking about cocaine. Is usually obtained in a protonated form as its hydrochloride salt, cocaine hydrochloride. However, it can be converted to crack by treatment with a base. The structure of crack is shown below. Circle the atom. This is kind of crazy that MIT is teaching you about crack and cocaine. Well, I hope this video doesn't get monitored for me talking about crack and cocaine. Scientific, guys. That's what Walter White said. Considering the solubilities of both these molecules, why is crack usually smoked but cocaine? Whoa. Oh, so it's not water soluble, basically. That's kind of cool. Super cool, actually. Super cool learning about crack, smoking crack. Let's go up here. Lesson 2. So this is what I'm missing. pKa, acid base, conjugate pair, Lewis acid base, nucleophile, electrophile. I think I did learn that a little bit. But Bronsted, Lowry acids and bases. Acids are proton donors and bases proton acceptors. The pKa quantifies acid strength. The lower pKa means a stronger acid. Understanding pKa helps predict reaction direction. Lewis acid bases, electron pair acceptors, extend the concept to non-proton reactions, key for mechanisms like electrophilic addition. Okay, this is a lot here. So I'm going to screenshot this. Oh, whoops, not that screenshot, this screenshot, which annoyingly doesn't show up here. Rate this like a 2, because there's a lot of confusing stuff here. I have an example reaction. So acetic acid and ammonia create acetate and the NH4 plus. So the conjugate acid, all right, pKa scale is the negative log of Ka. Oh, acid dissolution constant. Okay. HCl is -7. Carboxylic acid is 4 to 5. Phenols are about 10. Amines. So I'm supposed to memorize these for this, so I might as well screenshot that. We're going to have to make some Snapwise AI updates too. Predicting reaction direction. The equilibrium favors the side with the weaker acid, higher pKa. NH4 plus is a weaker acid than CH3COOH. So the reaction proceeds to the right. Okay, let me understand this. So equilibrium favors the side with the weaker acid. I need to understand that better. Lewis acids and bases. How long is this? These lessons are so long with the grok, but I guess that's kind of good. Why is acetic acid more acidic than ethanol? Its conjugate base is stabilized by resonance, charge delocalized over two O atoms, while ethanols is not, making acetic acid a stronger acid. That I need to understand better, for sure. Acetic acid is higher than, so are the things to consider when ranking acids based on acidity. It's interesting. I got so many fewer viewers when I stream later in the day as opposed to early. I don't know why that is, but it doesn't really matter. Mostly I just want commenters. I love it when people comment, like Kevin earlier. Cool seeing who you guys are, what you're into, what you're learning. All right. Flashcards for spaced repetition. An acid is a proton donor. pKa of NH3 plus is less than this, so H2O is the weaker acid. Were all these values in what I memorized? Water is 15.7, alcohol, CH3OH, 15. Phenol, I needed to get phenol down. It should be on my list of things to memorize. H to the C to the L. Okay, interesting. Factors affecting acidity are resonance, which stabilizes the conjugate base, increases acidity. More electronegative atoms stabilize negative charge in the conjugate base. Boy, this is so dense, man. Yo, what happened to my chat? Oh, there we go. More electronegative atoms stabilize negative charge in the conjugate base. Hybridization, more S character in the bond to H increases acidity. Okay. So I have to see which is the acid, which is the base. Why does CH3COOH donate a proton to NH3? Because it is a stronger acid. So whichever one's the stronger acid means that one transfers the proton to the other one. Okay, that makes some sense. Why does this chat keep disappearing? All right. Identifying the Lewis acid base. BF3 and NH3. BF3 is a Lewis acid because it accepts the electron pair, empty p orbital on B. Yeah, boron has an empty p orbital, I know that. And NH3 is the Lewis base. Oh boy. These are good practice questions. I need to predict the equilibrium direction. This one is going to move towards this way. So it'll favor the left because why does the equilibrium favor reactants? The weaker acid dominates at equilibrium. I want to say like why does the weaker acid dominate at equilibrium? Explain more about how being a weak or strong acid causes reaction to go left or right. Okay, so resonance stabilization. If the conjugate base after losing H plus has a resonance, it's more stable, increasing acidity. I don't understand how having resonance makes it more stable. To me, that would seem like it's less stable because it's got multiple orientations. What textbook are you using to base your knowledge off of and get your practice problems? Or are you solely using AI? Well, I actually originally put in Clayton's organic chemistry textbook because a viewer suggested that as part of my initial AI prompt to generate the curriculum. But I felt like they were sort of, I don't know, it didn't feel optimal. And it was referencing that too much. I thought the AI would be better just kind of doing its thing, knowing that I wanted to do this in only 3 weeks. So now I'm solely using AI. I'm using Grok as well as GPT-4o, but primarily Grok for the curriculum and the lessons, and then GPT-4o to mostly do image recognition. It's way better at that than Grok. I already had an issue that bothered me with Grok image recognition where it couldn't read the chemical formula and just gave me some unrelated answer when I was asking about something. And obviously OChem is very visual, so that matters a lot. And then in terms of yeah, so I'm not I'm not using a textbook right now. I'll look into OChem textbooks after this, kind of like I'm going to look into linear algebra stuff later on to solidify my knowledge. You know, it's not like I'm going to just learn this in 3 weeks and then never visit it again. I know too much about how the brain works. I don't know that much, but I know enough that it's not optimal to just bail as soon as you learn something in 3 weeks. I need to keep applying this, which is why I'm going to keep learning things that involve some organic chemistry, I think, which I talked a little bit about earlier. But yeah. Oh boy. Okay, resonance stabilization of the conjugate base. Why does resonance make something more stable? Explain from first principles. I think this whole first principles thing is interesting too. I read some, I think it was very much like Chinese propaganda tweet saying that DeepSeek R2 from first principles was able to make a room temperature fusion generator in just an hour and all these kind of things. But the idea of first principles AI reasoning to solve human issues is, I think, really cool and encouraging potentially. So yeah, how am I going to assess your knowledge base? Different textbooks cover different topics. How are you going to assess your knowledge at the end? MIT OpenCourseWare has their organic chemistry tests, and then there's also this thing called the ACS I learned. That's like an official organic chemistry test you can order. So I'm going to do the ACS after OChem 2, and I'm going to take the MIT assessments. I guess my first one will be on day 5 or so. So that's coming up Thursday most likely. Wow, that'll be rough. But yeah, I'm going to use the official MIT tests. I did say prepare me for these MIT tests based on the MIT curriculum a little bit. That's again all open source, so I thought it was good. The AIs can just go to the MIT site and use that information. So we'll see. Let's see what this response said. Right. Why does resonance is allows electrons to delocalize, spread out basically, over multiple atoms, reducing electron repulsion. So if they can spread out, it reduces electron repulsion distributes charge more evenly. That makes sense that delocalizing means charge is more evenly distributed. Lowering the overall energy of the system. Cool. I love the first principles breakdown. Sweet. Stability in chemistry refers to a molecule's tendency to resist change. Nice. I'm glad they had defined stability. I didn't even necessarily have a clear understanding of what that means. A more stable molecule has lower energy. Lower energy means it requires more energy to break bonds or undergo reactions. Nice. So that's like an activation energy. The primary driver of stability is how electrons are arranged, as electrons determine bonding and IMFs. That's interesting because my understanding of electrons is that they're all over the place. An orbital is just is a probability area. It's not actually like a clean orbit. We can't simultaneously know where an electron is and the direction in which it's going. That's sort of Heisenberg uncertainty. I'm showing my high school chemistry knowledge, my understanding of it right now. It lacks mathematical or higher level rigor, but basically the primary drive of stability is how electrons are arranged. Electrons can be arranged, though, just by coincidence, I'd imagine, in either a way that would drive more stability or less stability, even if their orbitals are in one way or another. That'd be my guess. Oh, cool. Thanks, Josh. That's actually really good. You took OChem last year at your university. Tell me about your experience with OChem. I'm curious to know what you found helpful, what advice you'd give to someone trying to take it the way I am right now using AI. Did you use AI when you were taking the course at your university? I know that's looked at in different ways at different universities. Some are more embracing it, some are outright banning it. But I imagine it's at least a helpful resource to consult. And that probably is the optimal way of learning right now, is use a textbook and an expert like a professor and TAs or other people, human resources, where you trust the knowledge, and then supplement that with AIs to get quick answers and clarify things. Gee. Keeping a floss pick at the table, low-key life hack. Always forget to floss my teeth, but it's right here. So high electron repulsion increases molecular energy. So having electrons farther away from you. This is Vesper theory, valence shell electron pair repulsion. Okay. Uh-huh. Uh-huh. Oh, this is interesting. So the actual structure is a resonance hybrid, a weighted average. Yeah, I think the AI in just you took this last year. The last year, it's gotten so much better at higher level math and chemistry. A lot of people, when I was doing linear algebra, were saying AI is wrong all the time on linear algebra. And I had to be wrong like 3 times in the whole entirety of my 30 days learning linear algebra with AI. And it was more like 3 weeks. I say 30 days, but I kind of just took my time to stream here or there when I could the last 9 days. Electron delocalization and repulsion. So in a resonance hybrid, electrons, typically pi electrons, and I understand what pi electrons are now, are not fixed in one position, but are delocalized across multiple atoms. Resonance energy. So resonance leads to a phenomenon called resonance energy or delocalization energy, which quantifies the stability gain. This is the energy difference between the actual molecule, the resonance hybrid, and the most stable. This is what I was talking about a little bit about electrons moving, and sometimes they'll be more stable than others. Cool. Oh, and look at this. They can actually kind of draw molecular diagrams. That's neat. Yeah, I'm gonna have to look at it. This is an experiment, I might just flunk these tests, and then I need it. This isn't like a foregone conclusion that I'm gonna learn organic chemistry well enough to pass these tests in just 3 weeks using only AI 1 hour a day. So I might fail these, but I am gonna look at a textbook eventually. If you have a recommendation on a textbook, let me know, because I will want to consult that later on. And I'll have a lot of aha moments where I maybe had 3 of the 4 pieces of the puzzle, but the textbook was able to visualize it, and then all of a sudden, a whole cascade of concepts will click for me, hopefully. We'll see. 35 minutes. I have to go soon, guys. I'm going to wrap the stream up shortly. Resonance often involves delocalizing charge, which further enhances stability. High electron density. Yeah, okay. Intermediate bond orders. I'm not sure what that means. Oh, they're neither fully single nor double, often resulting in a more uniform distribution. Oh, okay. Basically, when stuff's trapped in a single or double bond, that increases the energy of the atom, I guess, because electrons are localized. Okay. Oh, what did ChatGPT say to all this? Why does the universe use chemistry like this? Yes, this is going to be a banger. This is going to be a banger. All right, I asked it about why organic chemistry makes sense from a theoretical physics standpoint. Electrons, fermions, obeying quantum mechanics, nuclei bound by strong nuclear force, and everything subject to electromagnetism. They're already going at a higher level. I want a lower level understanding, like why electromagnetism, why nuclei, why electrons, as a way of, conveying information, which I think is what the universe does. I want to get into theoretical physics later too. Like mysteries of the universe is a goal. I know there's zero chance that I discover anything useful in terms of the mysteries of the universe before some artificial general intelligence, ASI, artificial super intelligence does, but I really want to understand it when it happens. Like I'm going to get to the point with this experiment within a year. I'll be able to understand relativity. I'll be able to understand a lot of stuff that I don't right now. So that's why it's really exciting, just doing an hour per day. It's a habit that I think a lot of people could get too. Like stream yourself learning for an hour per day with an accelerated AI curriculum. It's remarkable, for me at least, how much you learn. And I love seeing the people tuning in. So let's look here. Chemistry is the emergent behavior of electrons obeying quantum mechanics, nuclei, strong nuclear force. Electrons fill orbitals in predictable quantum ways. Carbon is uniquely suited. Yeah, so because it has 4 stable covalent bonds. Are all organic molecules living? No. Life is emergent complexity. Wow, biologists don't fully agree on one correct definition of life, but many point to these features. I forgot to wear my suit for this stream. Wow, what a schlub. Where's my suit? I was wearing a suit earlier. Here's my jacket. I'm gonna put this on. I always try to dress well for these streams. Hopefully no one critiques. So I just put on my blazer. I know it's not proper. So, are organic molecules living? No. They're building blocks like letters in a language. Viruses, debatable. They replicate, but not independently. They need hosts. So borderline. Cells, yes. Okay. So replication was my understanding of life, but it's more than that. It's metabolism, transforming energy to stay ordered. Interesting. That's what metabolism means. Response to stimuli. Aha. The whole causality complex of the universe, I think, is really interesting. Like, is cause and effect? I know it's how we understand things. Response to stimuli. We are living things. This is one of our core aspects. But is that true of life? The whole scientific, I guess there's Noether's theorem or something like that. Emily Noether has something about cause and effect, but I'm not sure that it's actually like if cause and effect don't matter to understanding the meaning of life and the meaning of the universe, then kind of breaks our whole capacity for understanding it to a degree, because that's what science is based off of. I'm rambling about the universe, but Texas, Carrie and Giuliano, Organic Chemistry, 12th edition, McGraw-Hill, during your Orgo class. Cool. Carrie and Giuliano, Organic Chem. I'll write that down. Remember that. Are organic molecules living? So why life at all? When you let atoms play long enough in a stable environment with energy gradients, the sun, time, and molecules that can form stable information-carrying systems, carbon-based polymers. Are there any molecules, microphone this, are there any molecules like carbon that would be candidates for being the building blocks of life? I don't understand why carbon's the only one. It's not arbitrary, it's just what works. That's such a BS understanding. It's like glazing over. Glaze is the new word that the kids say these days, I guess. But ChatGPT 4.0 has been known to glaze. 4 valence electrons. Give me some other ones. Yeah. Silicon. Also, let me look at a periodic table. Whoops, periodic table. Yep, silicon right below. Also 4 bonds. Inert silicates. Can make polymers. Not self-replicating, though. Boron, nitrogen, or phosphorus. Electron deficient, less stable, make stable rings. Exotic chemistry, but not the flexible rich variety of information needed for information-based life. That's helpful. Okay, cool. Interesting stuff, guys. Thanks so much for tuning in. I appreciate every single one of you who watches this, who comments, and I'm going to leave this with the Hemingway rule, which is I need to leave it with something I can pick up with next time. Some simple practice problems. View from lessons 1 to 2, and give me, I'll start with this, lessons 1 to 2. I didn't even get to lesson 3 yet. But I'm coming up on my hour for the day, so I gotta wrap it up shortly. What was lesson 4 gonna be? I don't even remember. All right. I got these practice problems to review. Should be good. Workspaces. I don't even know how all these features are. Personas. Unhinged comedian. Loyal friend. Homework helper. Not a doctor. Not a therapist. Interesting. Okay. Grok has a lot of stuff. I gotta look into it. Organic chemistry as a second language by David Klein. Ooh, that's cool. I like it. Look at this jank right here. Oh, it has my old name. This is for the vertical line, this thing. DWT, don't waste time. So, okay. Let me go to my history. I want to open this one. I want to find the Canvas where it has the whole curriculum. That would be helpful. First, I asked it to evaluate, to find the best AI for a curriculum. Then it did this whole thing. Then it did all this. Okay, whatever. I'm just going to keep going. Hybridization, resonance, pKa, conjugate pairs. I feel like I'm decent on that, honestly. And if I just take a quick, this is going to be super quick, not cheating, look at the exams. Exam 1, how long is this thing? 10 pages, oof. 104 total points. Asking like pKa's and stuff. Rank these in order of priority. Chiral molecule. To know some pKa values. I have to memorize pKa values. Okay, so that's good to know. I'm just glancing this really quick. Sets of molecules in order of reactivity, of acidity. Yep. Label all the functional groups. I have to recognize and get my functional groups down. So that's my main thing. I'm trying to do some spaced repetition review outside of this, but I need to get my functional groups down and some other things. But you guys, thanks for tuning in. I'll catch you all in the next one. Peace.